And good morning, everyone. Today we're going to be taking a look at how to prove the quadratic formula. And the quadratic formula is oftentimes used to solve equations that look like this. ax squared plus bx plus c equals 0. Normally, if you want to solve an equation, if you can factor it and solve it that way, that's a really good way to do it. But sometimes it's difficult to know how to factor it. You have to guess so much. Or sometimes it can't be factored with integers. You're going to need some decimals or some square roots. When those things happen, the quadratic formula is really helpful because it allows you to solve quadratic equations without having to factor them. That quadratic formula, by the way, looks like this. X equals negative b plus or minus the square root 4b squared minus 4ac all over 2a. But the question is, where does this formula come from? It's not magic. It's not true just because I say it's true. There's a reason why this formula works. And we're going to do something called proof, but really when you try to figure out where a formula comes from, the name for that is, it's called a derivation proof. We're going to derive where this formula comes from. To do that, we're going to start with ax squared plus bx plus c is equal to 0. And we're going to complete the square on this. Now, the first thing you have to know about completing the square is that you can't find that magic number that I've been talking about unless that term right there has a coefficient of 1. And right now it doesn't. It has a coefficient of a. It's super helpful if you start by just dividing both sides of this whole equation by a. And when you do, this for big fat fraction right here will actually turn into ax squared over a plus bx over a plus c over a. Sometimes people ask me, why can you actually do this, splitting it up into 3 fractions like this? And really, if you think about it backwards, these 3 fractions are being added together. They have common denominators. If you're to add these 3 fractions together, you take this numerator, and this numerator, add them all up just like you have right here, here, and here, and put it over its common denominator. We're like undoing the adding of fractions with common denominators. And it's helpful because this way the a's cancel and go away. Now that I have it written like this, now I can start to group the x's together, just like we normally do, and find the magic number. Normally when you find a magic number, I tell people to take the coefficient of the x, cut it in half, and square it. That's quite a bit more complicated in this problem. Say the coefficient of the x is going to be this stuff right here. The b over the a. That's the coefficient on the x. So that magic number is, we got to take that coefficient b over a. We need to cut it in half and then square it. Normally if you cut something in half, you can divide it by 2. But if that's uncomfortable or awkward, if you want to cut something in half, you can also multiply it by 1/2. Multiplying by 1/2 is the same thing as dividing by 2. After you cut it in half, then we're supposed to square it. And that is going to turn into 1 times b is b, 2 times a is going to be 2a, and still with a square on it. b, when you square it, becomes b squared. 2 squared is going to be 4, and a, when you square it, is just a squared. And this right here is going to be our magic number. Now I'm going to come back to this equation I've been working on. I'm going to say I've got x squared plus b over ax. And I'm going to give it the magic number. I'm going to add in plus b squared over 4a squared. Don't forget this c over a, that's supposed to be right there. Don't forget this equals 0, that's right there. Now, if you look at this from here to here, I haven't changed much. I still have the x squared. I still have this term right here. I've added in something, and then I've also kept that one right there, right here. But you can't just add something in. That changes the equation. So if you do give it something, you also have to take it back. And if I were to simply subtract a b squared over 4a squared, now this and this could actually cancel and go away. And then if you look at the equation, it truly is the same as what it was just a moment ago. Next, now that I've added and subtracted the magic number, it's time to do some factoring. And this thing right here, while it looks complicated and awkward, it's going to factor really, really perfectly. I'm going to set up my pair of parentheses and go what times what makes x squared, x and x. Now I'm going to go what times what makes b squared over 4a squared. Well, it is a fraction. If I just said what times what makes b squared, well, that would be b times b. And then what times what makes 4a squared? That's going to be 2a and 2a. It is positive. I'm going to try it with a plus plus. It is interesting to note if you check your cross term with the nose, these two, and the eyes, if you're in my class, they will definitely add up to the b over a. It's going to be perfect. Think about it. B over 2a plus another b over 2a makes 2b over 2a. When the 2's cancel, you get b over a, just like I have right here. If you haven't done that on your own at some point, definitely multiply it all out and really check for yourself to see that the cross term works. Over here, I've got a couple of fractions and I'd like to add them together. If I have a c over a and a negative b squared over, let me factor that up a little bit, 2a squared is the same thing as 4 times a times a. You might not need to do that extra step right there that I'm doing, but it helps me a little bit to see that what is this denominator missing that this one has? It's missing a 4, so I'm going to multiply top and bottom by 4. But it's also got an a, but it doesn't have 2 of them, so it's missing an a. I'm going to multiply the top by a and this bottom by a. Now, 4a divided by 4a, that's just 1, so it's okay to do this. But now I'm going to have my common denominators. Back over here now, x plus b over 2a times x plus b over 2a, that's the same thing written twice, which means that altogether it's going to be x plus b over 2a, all raised to the second power. And then here, 4ac take away b squared, that's going to be 4ac take away b squared all over 4a squared, and still equals 0. We're getting close to wrapping this up. I have completed the square now. And what I'm still trying to do is I'm trying to get the x by itself. Although it looks still kind of complicated, one thing that's really nice now is if you count how many x's do you see in this equation, count carefully. Nope, 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 nope. There it is, just one x. And that's going to be what's going to allow us to solve and get x by itself. Whereas, back up in the beginning, how many x's do you see in the equation? Nope, 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 yep. There's 2 x's, and they're not even like terms. And this is what makes it so that it's almost impossible to get x all by itself. So all these steps, almost its entire goal was to get it down to having 1 x in the problem instead of having multiple x's. If you want to get to this x, what I'm going to do next is very similar to if I had a much shorter, simpler problem like this. If I had x plus 3 with a square minus 9 is equal to 0. If I was going to solve a simple problem like this, I would do it by just going, well, add 9 to both sides. Now I get x plus 3 squared, that would equal 9. Next, I would need to take the square root of both sides, so I take the square root of this side, the square root of that side. The square and the square root, they will cancel, leaving an x plus 3 is equal to, and don't forget when you square root both sides, you're supposed to put a plus or a minus on it. That's going to be a plus or minus 3. And then finally, I'm going to subtract a 3 from both sides, like this. Those 3's will cancel, and I'll get x equals -3 plus or minus 3, which in this particular case will turn into x is equal to -3 plus 3 is 0, and -3 minus 3 is -6. Now, this little problem right here, I know it's much shorter and simpler looking, but it's the same thing that we're about to do right here. So I actually want to start by getting the 9, and I want to move it over to the other side. This here I added 9 to both sides, but since this one's positive, if I want to get rid of this big monster right here, I'm going to subtract it from both sides like this. Minus 4ac minus b squared over 4a squared, and minus 4ac minus b squared over 4a squared. This thing right here is going to come down, and I'm going to get x plus b over 2a squared. These are going to cancel and go away, just like the 9's did. And 0, take away that, is going to be negative. And I'm sorry, I see that negative sign right there? I put it up high with the 4. It should be out front right there because it's subtracting the whole thing. Minus 4ac take away b squared all over 4a squared. On my little problem, when I wanted to get rid of a square, we took the square root of both sides. And I'll do just that. I'm going to take the square root of this side, and I'll take the square root of this side. And I was a little nervous because I thought, oh no, I can't take the square root of a negative number, but this is a lot of variables in here. I can't truly know if the answer is going to be negative or positive because it really depends on what the answer to this fraction works out to be. It won't be negative all the time. This square and this square root cancels just like they did over here, and I get x plus b over 2a equals, and don't forget when you take the square root of both sides, you should definitely put a plus or minus because there's going to be 2 answers. That's related to the fact that we're finding the x-intercepts, and usually when you have a parabola, it usually crosses the x-axis in 2 spots. Also, this negative sign right here, there's technically parentheses right here, even if we didn't take the time to write them. And I'm going to distribute that minus sign through those parentheses like this, and end up getting plus or minus square root. That's going to be negative 4ac plus b squared all over 4a squared. We're just about to get the x all by itself. You can see I've got this x plus this. If I could just get rid of this part right here, I think we'd be done with the problem. Remember, our goal is we're trying to prove or derive the quadratic formula. And we'll know when we're done is when we end up with something that looks exactly like that. And that will mean that this is no longer a mystery. This is no longer just true because a math teacher says it's true. We'll know exactly why it's true because we have derived it by proving it through derivation. So to get the x by itself, I am going to subtract a b over 2a from this side and subtract a b over 2a from this side. These, of course, will cancel and go away, leaving a plain x equals. These are not anywhere close to being like terms yet, so I'm just going to copy them down. I'm going to put the negative b over 2a first, plus or minus. Notice my square root. This is what I like to call a double-decker square root. I went real low with it, and I was telling everybody that the whole thing is in the square root. What I want to do, though, is I want to simplify it a little bit, noticing that the square root of 4, I know what that answer is, and that answer is 2. And the square root of an a squared is just plain a. And now that I've taken its square root, don't put a square root sign on the 2a. Just put a square root sign on the stuff that remains at the top. Also, This is a pretty ugly order to write things in. It's usually uncommon to have something start with a negative sign. It would be nice to put the b squared first. And then that minus 4ac, I'll put that next. Notice my square root, it is not a double-decker square root. If I were to make it long and tall, it would be wrong. I have to keep that square root sign now just on top. I gotta make it long enough so it covers all the way past the C. Tell yourself this, if it was raining out, would the C get wet? And if the answer is no, you did a good job because you're telling everybody that everything underneath there is under the square root sign. Last, I want to add these two fractions together. They do have common denominators, so it's super simple to do it. When you add things with common denominators, that 2a and that 2a become the common denominator right here. And the numerators, the negative b, you just add or subtract to this square root right here. And sure enough, this is turned into the quadratic formula. This has been a derivation of proving why the quadratic formula works. We've derived the formula. I hope this helps you understand that formulas that are complicated like this, they're not just made up, they come from someplace. And this is the process of figuring out where do those formulas come from and why do they work. Thanks so much for learning with me.